Alright, so in this video, we're going to be looking at limits graphically and using a table. So let's first look at our table. Whoops. So if we look at our table, actually before we look at our table, let's just review what a limit is, right? So we write out a limit like this. We've seen this before. The limit as x approaches a for a function, let's say f of x, this is equal to L, right? What does this tell us? X as x, right, approaches a certain number. In this case, it's a. It looks like a 9, but it's a. As x is getting closer and closer to some number a, the function values are getting closer and closer to some value, and that value that they're getting closer and closer to as x approaches a is L, and that is your limit. So that's what it's telling us. If we were to look at that graphically, which we will in a second, that would be very similar to what I just said, right? As x approaches a certain value a from the left and from the right for the function f of x, then the function values are getting closer and closer to a certain number, and that number is L, which is your limit. So that's what a limit essentially is, right? So now that we know that, let's look at our table. So in this case, our x values are getting closer and closer to a certain number in this direction. As you can see, we have 1.9, 1.999, 1.49s, right? They're clearly getting closer and closer to a certain number, and as you can guess, that would be 2. So that would be the limit as x approaches 2. But this is not just the limit as x approaches 2, because the limit as x approaches 2 means that we're looking at the positive and the negative direction. But here we're just looking at one direction, and that is the negative direction. So that's minus right there. So why is it the negative direction? If you look at a number line, right, we have 1, well, that's 2, let's say it's 2, this is 1, this is 0. We're getting closer and closer to 2 from this direction, essentially, which is the negative direction. And if we were to do it from this direction, that would be the positive direction. So at limit as x approaches 2 from the negative direction, for the function 2x squared, right, what is that going to be equal to? Well, that is going to be equal to what function values are we approaching as x approaches 2 from the negative direction? Well, we're getting closer and closer to, so this is 7.22, 7.992, something, 7.9992. So clearly we're getting closer and closer to 8, right? The function value is getting closer and closer to 8. That's our limit. That's our one-sided limit. Now let's look at the other side, right? From the positive direction. So from this direction. So from the positive direction, we're still getting closer and closer to 2, and our our function values, are also getting closer and closer to a certain number. That's 8. So if I were to write it out, that would be the limit as x approaches 2 from the positive direction for the function 2x squared is going to be equal to 8. So since our one-sided limits are equal, if I were to write it in a general color, since our one-sided limits are equal, this tells us that the limit as x approaches 2 for the function 2x squared is just equal to 8. Since this and this is equal, we can say this. So that's what our table told us, right? Our table was giving us information so that we can essentially write this. So this is very useful. Whenever you have a table and they say write a limit using this table, you have to look at the x values and see what they're approaching. And in this case, we got this limit as x approaches 2 for 2x squared is equal to 8. Now let's look at this exact limit on this graph. So let's look at this limit on this graph. So x is approaching 2 from the left and from the right. So let's look at that. So from the left, do that in green, where as x approaches 2 from the left, the function values are getting closer and closer to, well, they're getting closer and closer to 8, right? That's exactly what we saw over here. And if we do that from the right, and we don't have a lot of space, but if we do it from the right, from this direction essentially, and we have more x values over there, but this is all my graph has, we're still getting closer and closer to that 8, right? So that's just the common point right over there. We do that in black. This is the point that we're getting closer and closer to from both directions. So we still have this. So the limit as x approaches 2 from the negative direction, this is the negative direction. As the function values are approaching 8, and from the positive direction, the function values are approaching 8. So the limit as x approaches 2 from the negative direction and the limit as x approaches 2 from the positive direction for 2x squared are equal, which tells us that the limit as x approaches 2 for 2x squared is equal to 8. So we were able to look at a graph and at a table to essentially write out a limit and to understand it. This is very useful, and I'd encourage you to practice this a lot more, because looking at limits using a graph and using a table could be really important when you take tests and when you just try to understand limits a lot more deeper. So I hope you found this video helpful, and it's important that you realize one important thing from this video, that limits can be solved very easily by looking at x values that are getting closer and closer to that number that you want. So I hope that was a very clear message in this video.